Hello everyone, I'm Vedant from Georgia Tech. I'm going to share our findings on using computer-assisted approaches to protect time at information work. This study was done in collaboration with Microsoft during my internship last summer. In information work, people have to juggle many different tasks like coding or making presentations, but also emails and meetings. And on top of that, they also need to cope with their work-life demands. In theory, flexible work should allow you to do everything, but in practice, without sufficient time, there's a struggle to do many different things. This can lead to stress affecting workers' well-being and also slowly take away their ability to perform. As such, information workers need to protect their time, and we want to study what is the value of doing this through a computer-assisted approach. There are many other approaches. On the left, what you're seeing is Benjamin Franklin's planner. He was protecting time by quite simply defining purpose and setting goals. You can also go to your own digital calendar and mark a time as busy, and that will avoid others from blocking that same period of time. Or you can use a time protection plan by Viva Insights. This particular feature preemptively blocks out periods of time for you to use for yourself. This is what I refer to as computer assisted protected time or CAP time. So let's look at this feature more closely. It's called focus time. So it sets up periods preemptively through your week. During those periods, nobody else can block a meeting. Your notifications will be blocked itself. Also, you'll be reminded of your goals, and all of this is automated, so there's very little user burden. But that will make you start wondering if it actually works. And more importantly, when information workers are remote and working in more flexible ways, will they actually be using their time properly with such a technique? So we investigate this question at very different levels. At the first level, we study how these periods of protected time are used. Second, we study how days with more protected time vary. And lastly, we look at the differences between individuals who use protected time and those who do not. We studied two data sets of information workers, and both of these were collected in the wild. To jump right into our first research question, we wanted to understand what information workers are actually doing during cap time. So we wanted to distinguish these behaviors from other kinds of periods typically found in an information worker's schedule. So that can be one-on-one meetings, time they've protected for themselves, as well as unscheduled periods of time. We were studying the behaviors of 27 information workers, and we had approximately 1 month of data, which included self-reports as well as digital activity. To understand our digital activity logging better, I'm showing you a visualization of one of our participants during one of the days in that study. For this analysis, we broke everything into 30-minute chunks, and that's what those dashed vertical lines represent. Different rows show the different kinds of activities we could log, such as meetings and coding, and we could do that for different periods of time, whether it was during a meeting or whether it was during cap time. For the analysis, we built mixed effects models, and our dependent variable was essentially these different activities or the self-report during that time. We also controlled for fixed effects like personality. But in addition to that, because our observations were not independent, we included random effects. For example, one individual might have had multiple periods of data. The same day of the week could also have multiple periods of data as well. Then we looked into different ways individuals are working. And that's the first thing we're going to see right now. There were many different categories of activities, but I will only focus on synchronous communication and coding and development for this talk. First, the confirmatory finding. Synchronous communication indeed reduced during cap time. Workers could self-initiate themselves to check communications, but still, compared to something like, say, unscheduled time, where keeping everything the same, if anything, their engagement in communication would increase by 11%. But in coding, we see the opposite trend. Compared to all other kinds of times, we observed more engagement on coding and development during cap time, and arguably, this might appear as a small effect size. It's 8 to 11% increase compared to other periods. But remember, our model is only capturing traces of activity. It does not entirely reflect the brain work that's being involved in this activity. But now let's look into the well-being aspect. We looked into how workers reported the ratio of job demands and resources. The way we can think of this is that when workers have more demands than resources available, they can consider that a threat, and that's negative for their well-being. But if they have enough resources to meet the demands, then it can be considered a challenge, which is generally considered positive. During cap time, workers showed significantly lower ratio, so they had more resources to deal with their demands. In fact, cap time showed no difference from unscheduled periods of times in terms of their well-being. So collectively, we found different trends. We actually first also saw that workers were available during cap time. We have the details of that in the paper. But they also reduced the communication and instead increase task-specific engagement such as coding. And all of this while managing their well-being better. we need to understand how would this affect the entirety of the day. Specifically, what would happen if we accumulate cap time over a day? Well, the first thing that we found was there was actually no significant effect of including more cap time in a day to your overall engagement with coding or communication. So what we suspect might be happening is a reorganization. If you notice the graph on the right, it shows on the first row a day without any kind of cap time. In the second row, what we're seeing is a day which has some cap time. What we suspect might be happening is that while we've seen that engagement during cap time increases, since overall daily changes don't happen, they might just be relaxing their engagement during other times. To test this more formally, we looked at three different time management measures. First, we looked at the total number of hours they were active in a day. Then, we looked at the time between their first and the last hour. And lastly, we were looking at their engagement after 6 p.m. as an indicator of after hours work. While we saw a reduction in all these measures, we actually found that the engagement after 6 p.m. significantly reduced. Note, we also saw reductions during self-assigned protected time as well as one-on-one meetings. However, the effect of cap time on reducing the engagement after hours was larger. So at a day level, we mostly witnessed some form of rearrangement in a worker's day, even though we were seeing momentary differences in their overall behavior. But all the things we've seen so far is for workers who've already been using cap time. They might have had certain predispositions, they might have learned to use it well. What if we were to give cap time to fresh users? That's why we're going to dive into our second study and answer our third research question. So for this third question, we recruited 89 workers, each of whom was now hybrid. We split them into two groups based on uniform characteristics, and after 1 week, we set up cap time for some of them. And then we were comparing the daily activities and the self-reports along against their base. Then we compared the daily activities and self-reports against their own baselines. So we used a very similar design as we'd already seen, but now we had an additional level to account for. So we included layers for caregiving load, as well as individuals who had multiple direct reports to themselves, as we believe those could affect how they use their cap time. So what did we find here? Well, firstly, we found that workers were actually reporting more performance compared to those that did not have cap time. So if you look at the graph, how to read that is the blue line represents the workers with cap time. The y-axis is just a normalization, and you can see that the individuals with cap time were actually reporting higher performance than what they did during the baseline. So this increase in task proficiency, based on what our subjective responses were, we believe it could be because participants were planning their activities, and focus time was also giving them the goal and intention, but also the ability to execute that plan. Interestingly enough, while people were reporting the high performance, the individuals with cap time also were logging fewer hours of engagement. In fact, people without cap time had to spend some more time than their baseline in the initial weeks. Whereas if you look at those in cap time and you look at P48's code, they were learning to work more efficiently. So cap was actually helping complete certain tasks and thus free up their day. This actually reflects what we learned from our insight for RQ2. And it wasn't just a change in time. These participants also reported an increase in their available resources. So if you notice the graph on the right, the smaller one, we actually first noticed a general trend towards increasing work pace. For those without cap time, this increased work pace led to a spiraling decline of resources over time. That's why you're seeing that red line plummet down. Potentially, what we were seeing in the case of users off cap time is that they were more relieved because they did not need to be disrupted and they did not need to be responding immediately. Taken together, for new users, we saw that cap time can actually lead to perceptual differences of well-being, but it can actually also lead to behavioral differences in how they complete their work. Of course, cap time, as we studied it so far, is far from perfect. In our paper, we were looking at just one such instance, and we've also discussed many of the edge case perspectives where workers did not gain any benefit. So we believe this gives an opportunity to build more intelligent cap time systems. For example, we can learn the rhythms of an individual's day and find out what will be the best part to protect time where a worker might be most attentive. Or we can learn how to selectively manage notifications to allow some communication through cap time. Similarly, our findings also inspire more sociocultural changes in how we perceive flexible work, especially in the context of time. Most importantly, we need to give workers more agency so that they can control how they use their time. We discuss all of this extensively in our paper, along with the limitations of our methodology. Before I go, I wanted to thank all the wonderful folks at Microsoft who made this study possible, and many thanks to all of you for listening.